Hello class, this is a video tutorial on what happens if we get a zero indice and negative indices. So let's begin with a zero indice. The long story short is that anything to the power of 0, so x to the power of 0, it seems odd, but it will always give you 1. Even if you have 3 to the power of 0, it still is 1. Even if you have a weird expression like this, if you have 2z squared to the power of 0, like that, that's still 1. Now you may be asking yourself, why is that? Well, let's explore that idea now. So let's think about this idea of 0. Isn't 0 2 minus 2, that's equal to 0, or 1 minus 1, that's equal to 0, maybe 4 minus 4 equals 0, even x minus x is equal to 0. So anything minus itself, well, it will give you 0. So we use this idea to get this. So if you get, let's say, x to the power of 2 minus 2, 2 minus 2, that's x to the power of 0, that's equal to 1. Well, this x to the power of 2 minus 2, we saw that if you have things of the same base, that's x to the power of 2 divided by x to the power of 2, isn't that x to the power of 2 minus 2? So this is equal to this. But take a look, that's something divided by itself, hence why it's 1. And just to explain that a little bit better, if I get 5 divided by 5, that's equal to 1. So anything divided by itself is equal to 1. Hence why x to the power of 2 minus 2, which is x to the power of 0, is the same as x to the power of 2 divided by itself. If you got a little bit confused with that, just know this is an explanation for this rule. Anything to the power of 0 is equal to 1. But now what happens if we go less than 0? Indices that are less than 0. So let's take the idea of x to the power of negative 1. So how could something become a negative? Well, it must mean it would have been subtracted below 0. So if we take this idea, in order for it to be negative 1, it would have had to have been, for example, x to the power of 3 divided by x to the power of 4. Because that would give us x to the power of 3 minus 4, which is x to the power of negative 1. Okay, and what this would actually mean is the following. We can rewrite this expression, this one right here, as x to the power of 3 divided by x to the power of 4, like that. And we saw from expanded notation, that is x times x times x, 3 x's on the numerator, divided by x times x times times x. That's 4 on the bottom because it's x to the power of 4. And just like before, whoops, don't worry about that. We start crossing off 1 from the top for every 1 on the bottom. So there's 1x here, we cross that off. The top and bottom, top and bottom. Well, we're left with 1, but it's on the bottom. So that gives us 1 over x. So in short, if we have x to the power of -1, that is actually 1 over x. What happens then if we have x to the power of -2? Well, we get that as a result of, just for example, it could be x to the power of 5 divided by x to the power of 7, which will give us x to the power of 5 minus 7, which gives us x to the power of 5 minus 7 is -2. So let's explore this using expanded notation. So this expression is the same as x to the power of 5 divided by x to the power of 7. Writing this in expanded notation, there's 5 on top, x times x, that's 2, that's 3, that's 4, that's 5, 7 on the bottom, 1, 2, 3, 4, 5, 6, 7. And we cross off, and we start cancelling top and bottom for each one. So that's 1 on top, 1 on the bottom, 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 which leaves us with 2 at the bottom. But we know x times x is x to the power of 2, so there's nothing on top. We don't end with 1 because there's a times 1 here. So we just have 1 over x squared. So this actually becomes 1 over x squared. So in the long story short, if we have any expression x to the power of -n, this actually becomes 1 over x to the power of n. We'll just take a few examples of this now. So for example, if we had example 1, if we had 2 to the power of -3, that is actually the same as 1 over 2 to the power of 3. Well, 2 to the power of 3 is, let's have a look here, 2 to the power of 3 is 8. So that is 1 over 8. If we take, for example, example 2, if we had 3t to the power of -4, here's where it gets slightly tricky. Only the t goes to the bottom because this is 3 times t to the -4, which becomes 3 times 1 over t to the power of 4, which gives us 3 over t4 because it's just top times top. one last example. What if we have 4x squared y to the power of negative 3? Well, only the y will change. So that'll become 4x squared. That will separate off to the side. Y to the power of negative 3, which becomes 4x squared times 1 over y to the third, which is 4x squared over y 3. That is what happens with negative integers and what happens with 0 as your indice.